Evaluate the integral of the square root of x squared plus 1 times x to the 5th dx. Now, we've seen things like this before. We saw an example where it was x cubed, but not x to the 5th. And so we're going to use the same strategy that we have then. Specifically, we're going to make the substitution. Let u be x squared plus 1. And that means that du is 2x dx. And if we divide both sides by 2 to make things a little bit nicer, that gives us 1/2 du equals x dx. So what we need is we need there to be an x dx in our integrand. So let's go and split that out. So this is going to be the integral of the square root of x squared plus 1, which we know is going to be u. So that's going to be u. And then we need there to be an x dx, so we can split this up as x to the 4th times x dx. Now, we need to know what x to the 4th is in terms of u. And we've got u equals x squared plus 1. If we subtract 1 from both sides, that gives us x squared is u minus 1. And if we square that, that gives us x to the 4th equals u minus 1 quantity squared. And that is how we're going to have our x to the 4th. So now we're able to write everything in terms of u. So this is going to be the integral of the square root of u, and then times x to the 4th is u minus 1 quantity squared, and then times our x dx is going to be 1/2 du, and I'm going to put that 1/2 out front. And so we've got everything in terms of u, but it's still a little messy. Here's what I'm going to do. I'm going to take this u minus 1 quantity squared, and I'm going to actually multiply that out. So we're going to keep everything the same. But then u minus 1 quantity squared is u squared minus 2u plus 1. And the reason that's helpful is because we can then distribute the square root of u into each of those terms, and we can write them all as power functions. So I'm going to keep that 1/2 out front. Now, the square root of u is u to the 1/2, and so when we distribute it into the first term and add the exponents, 1/2 plus 2 is 2.5, and that's the same as 5/2. So this becomes u to the 5/2. And then minus 2 times the square root of u times u is going to be u to the 1/2 plus 1, or u to the 3/2. And then plus the square root of u times 1 is the square root of u. That's the same as u to the 1/2 with that du to the end. And once we've done that, we've got all of these as power functions. And so we can integrate each of them on their own. The integral of u to the 5/2, if we add 1 to the exponent, is u to the 7/2. That's going to be divided by 7/2, which is the same as times 2/7. And then minus 2 times the integral of u to the 3/2 is u to the 5/2. Divided by 5/2, which is the same as times 2/5. And then plus the integral of u to the 1/2 is u to the 3/2 divided by 3/2, which is the same as times 2/3. And one nice thing is that the 2 out front in the denominator cancels with all those 2's in the numerators. So then we end up having u to the 7/2 over 7 minus 2u to the 5/2 over 5 plus u to the 3/2 over 3 plus our constant of integration, which I forgot in the last step. Shame on me. And then we can't leave our answer like that. We've got to put everything back in terms of x. And so this first one is going to be x squared plus 1 to the 7/2 all over 7 minus 2 times x squared plus 1 to the 5/2 all over 5, and then plus x squared plus 1 to the 3/2 all over 3, plus our constant of integration, and that is our answer. It is a bit of a behemoth, but we were able to go through and get everything in terms of u and integrate it term by term and substitute back into x. So even though our answer has a lot of things going on, we were able to integrate, and that is what matters.